Welcome to the notes for section 4.0. We're going to call this one circular angles. And today we're going to review measuring angles in a circle, and our focus will be on degrees. So I'll go ahead and just kind of read what we're starting out with here. It says, working with angle measurement. You have probably always measured angles in degrees, but have you ever wondered why there are 360 of them in one whole circle? The concept of a degree was used to approximate a day in a year. Since 360 is divisible by many numbers, it was easier to use than the actual 5 1/4 days to represent a full circle. Many primitive calendars actually used 360 a year. Outside of its close approximation, a degree has no further mathematical significance. So really, that's the whole reason why there's 360 degrees is because 360 is close to the number of days in a year. So it was an easier number to use. All right, so let's go ahead here and let's review a little bit of the things that you hopefully learned in Algebra 2. But if you're a little rusty or you forgot, okay, we'll be able to pick up on that today. So measuring an angle in the unit circle. Okay, so angles in the unit circle are measured from the positive x-axis counterclockwise around the circle. Okay, this actually has a special name. This is called the standard position. Okay, this is the standard position. That's something that you need to know, and we'll talk a little bit more about that here as we go through this slide. The standard position is from the positive x-axis. Okay, so from the positive x-axis. And understand that the positive x-axis is right over here when you're looking at a coordinate plane. Okay, right? This is like our x-axis and our y-axis. Now, it says as we continue on, the angle measurements pass through the quadrants 1, 2, 3, and 4 in order. So since we are traveling around the circle counterclockwise, right, we're going to see here that we've got our first quadrant, right? So as we go up from like our standard position, that first quadrant is what we call quadrant 1, and then as we go around, quadrant 2 is like the top left. Quadrant 3 is the bottom left, and quadrant 4 is the bottom right. Hopefully you remember that, but just a good little review just in case. Okay, so as we travel around that way, right, so we are traveling counterclockwise. So counterclockwise, right, is like the opposite way of a clock, right? So when we go around the circle, we're going around this way. Our angles that are measured in this direction, remember, are going to be positive angles. So our positive angles are measured counterclockwise. And if we took it and we measured it going this direction from the standard position, right, these ones would be negative angles. So I know these are all things that you've hopefully learned in the past, but we're reviewing them just to make sure that we're all on the same page moving forward. Okay, so it says that the two rays are called the initial and terminal sides of the angle. So as I'm going around the circle, when I start at my standard position, right, this is my initial side of my angle, right? So let's kind of highlight that in yellow. That's our initial side of our angle. We know the angle is formed by those two rays. The other side of our angle, right, would be this part here, this ray. That one is what we call the terminal side of the angle. It makes sense, right? Think about initials. Think about your initials in your name, right? That's what your name starts with, like from your initials. And then like terminal, like think about a bus terminal. That's at the end of the bus route. Or say somebody is terminally ill, you've reached the end of your life cycle. Okay, so that's why they named them that. So we start our angle with the initial side and we end it at the terminal side. Okay, and then it just as a quick review here, it says that the variable theta, right, is often used to represent the angle measure. So we usually use that as a placeholder for unknown angle measures and things. Okay. Below here it says a unit circle. Okay, right? A unit circle is a circle whose radius is 1. Okay, and we'll review the unit circle here over the next few lessons to make sure that we remember what we need to know to be successful in pre-calculus this year. And then it says the central angle of any circle is, and we know this to be 360 degrees. Okay, so let's move on. It says, let's label the degree angle measures in this circle by dividing the circle into equal subdivisions. All right, so this is kind of our unit circle. When we look at it here, right, we know that our x-axis, right, runs along horizontally through our circle. This is our x-axis. And then our y-axis runs right through our circle vertically, just like this. Okay, that's our y-axis. All right, so when we're measuring our angles, we know that we usually start with 0 degrees. So over here on the left side, that's 0 degrees. And as we rotate, halfway around the circle over to here, we know that this one is 180 degrees, right? We're halfway around the circle. And then as we continue all the way back around the circle, it's another 180 degrees. So when we get back to 0, right, we could say that we've gone a total of 360 degrees. So our right side is 0 and 360, our left side is 180. Now, if we took that and we actually just traveled halfway around the circle, right, if we went just halfway around the circle, we could kind of look at what's our measurements going to be. So if we went half of that 180, remember that is going to form our 90-degree angle. And then, right, if we went halfway around the circle from there, right, we're just adding 180 degrees. That would put us at 90 plus 180 is 270. And then we're going to take it and break it into smaller subdivisions there. So if we go back up to the top side, looking in quadrant number 1, look at quadrant number 1 here, we've got, right, if we go halfway across quadrant 1, we know that this is our 45-degree angle. And so when we go halfway around the circle again from 45 degrees, right, if we took it here and we went halfway around the circle over to here, right, we just add up, that would put us at 225 degrees down here. And then we think about halfway from 90 to 180 degrees, right, should be 135 degrees. And if we go halfway around the circle from there, right, another 180 degrees around to here, 180 plus 135 would be 315 degrees. Now remember, these angles that are all marked in red here are what we call corresponding angles, or sometimes we refer to them as like butterfly angles. Okay, and we'll talk a little bit more about that later on. Okay, they all have the same reference angle, and we'll talk about it. The other angles that we need to make sure we remember then would be like this angle here, right, which is 15 degrees less than 45 would be 30 degrees, all right, which means if we go and we break this into smaller pieces, right, from here to here is 30 degrees. So if I go another 30 degrees to here, that would be 60. And then we've gone 30 to here is 90. And then we continue on another 30 degrees. This would be 120 degrees. Go another 30 degrees here. This would be 150 degrees. Go another 30, we're at the 180. Go 30 degrees past 180, we're at 210 degrees. Go 30 degrees past that's 240 degrees. Then we're down at the bottom at 270. Plus 30 more would be 300 degrees. Plus 30 more would be 330 degrees. And before you know it, we're all the way around the circle back at 360. These are the angle measures that we tend to use the most. Okay, these are the ones that you hopefully learned in the past, and we will use them a lot as we continue to move forward. Okay, and we will talk about a lot more of the terminology as we get deeper into the chapter. So, let's look here at this next slide. It says, draw both angles in the circle, and then it wants to know what is their relationship. So when we draw our angles in the unit circle, remember we've got a circle there, and it's got the x-axis and the y-axis on it. Remember, this is our initial side, so this is where our angles always start, right over here at 0. And since our first angle is 50 degrees, right, that's just going to be a little bit more than halfway through that first quadrant. So we'll just kind of estimate it to be about right here. All right, so we've opened up and we've gone from here to here. This is a 50-degree angle that we've measured from our standard position. Okay, now let's look at 410 degrees. Right, 410 degrees, right? We're going to start at the same initial side. It's also positive. But when I start going around the circle, right, this would be 90, 180, 270, 360, right? We've already gone all the way around the circle, so we're going to continue on here. So if we've gone already, we went 90, 180, 270, 360. How much more do we have left to go to get to 410? Well, that's another 50 degrees, so it's going to end up right here. So not only is this 50 degrees, but this is also our 410 degree mark. Okay, so both of these angles right here have the same terminal side, right? So they both started in the standard position and they both have the same terminal side. Okay, and we'll talk about that relationship here in a second. Let's also look at the second one. Okay, so the second one, again, we're starting in our standard position over here at 0, and we're going 200 degrees. So when we go 200, we're going to start here. We know that when we go from here to here, we've gone 90 degrees already. And then as we continue on down here, we've gone 180 degrees. Now we won't make it all the way down to 270 because we're going to go just a little bit past 180 degrees. So I'll estimate it to about right there. All right, so this would be our angle that is 200 degrees. Now, our second angle is negative 160 degrees. So remember, positive angles go counterclockwise. Remember, counterclockwise, like going backwards from a clock. Our negative angles are going to go clockwise. So when we start here at 0 for our negative 160 degrees, we're going to go this direction. So when I go down here, I'm at like negative 90 degrees. And I won't make it to negative 180 degrees, so I'm not going to make it halfway around. I need to go another 70 degrees from 90, so we're going to go about 70 degrees more, and you'll notice we hit in the same spot right here. Okay, so our 200 degree angle is also going to be the same spot as our negative 160 degree angle. So this right here, right, that terminal side is the terminal side for both of the angles here that are in the standard position. So what is their relationship, right? So we have each pair of angles share their terminal sides. Okay, with the other angles there. So all these have been graphed from the standard position. So what does that mean? Well, we call these coterminal angles. These are all coterminal angles. So what are coterminal angles by definition? Well, it's exactly what we just drew in. Okay, so if we're going to like define it for you or put it, on paper, we would say here that coterminal angles are two angles that share a terminal side when graphed from the standard position. We'll write that out. If you need to pause it, you can do that. But coterminal angles are angles. I don't even know why I wrote R angles. That's silly. Angles that share their terminal side or a terminal side when graphed from the standard position. So if we need to look back here one more time at the ones we just did, right? So for 50 degrees and 410 degrees, both positive angles, they both have that exact same initial side here, right? Our 50-degree angle, right, just goes up to here, so there's its terminal side. Where our 410, we went all the way around the circle, but then our terminal side ends up being in the same place. Okay, and it's also true for angles that are positive and negative, right? So starting at our standard position, if we went 200 degrees in the positive direction, that's where our terminal side would be. If we went negative 160 degrees, right, and then that would be where our terminal side would be as well. So 200 degrees and negative 160 degrees are also considered coterminal angles. So how to find coterminal angle values? Well, there's a couple ways you can do this. If we take an angle, and let's just kind of draw one in on your paper, right? So when we draw that out, right, I'm going to cheat, but like if I draw out kind of an angle, I'm going to draw a circle. See, that looks pretty good to me. Okay, and then I take it and let's think about, we've got our x-axis here, and we've got our y-axis. That might be off a little bit, but bear with me. Actually, I'm a little embarrassed by that. That's a little better. All right, so when I take an angle and I draw it in, I've got my initial side here, and let's just say we're going to measure out an angle that was, let's say, 100 degrees. Right? So 100 degrees, we know is a little bit past 90, so it's right up here. This would be like a 100-degree angle. Okay, so if I wanted to come up with a coterminal angle for this, right? I could think about it. I could take this angle and I could just go all the way around the circle till I get back to where the terminal side is. So if I take my terminal side of my angle and I add 360 degrees, where would I be? Well, if I started at 100 degrees and I just add 360 degrees, that would put me at 460 degrees. So I could say here that 100 degrees and 460 degrees are coterminal angles. Right? But we could also go the other direction. If I'm at my terminal side here, I'll try to do this one in green, right? Let's say that this was still, we're at 100 degrees, but instead of going counterclockwise, let's say I decided and kept going around until I got all the way back to here. Okay, I've gone 360 degrees again, but I've gone in the negative direction, right? So if I was at 100 degrees, but I went 360 degrees backwards, I would take away 360 degrees, right? And then what is 100 minus 360 degrees? Oh, looks like I lost my pen somehow. That's great, right in the middle of the video. That was cool. See if I can get it back. But as you do 100 minus 360, we should get negative 260 degrees, right? So we could say here that 100 degrees and negative 260 degrees are coterminal angles. Well, wouldn't that also then mean that, negative 260 degrees and 460 degrees would also be coterminal angles, right? Because they all share the same terminal side. Okay, so how to find coterminal angles? All we're going to do then is we're going to say we're going to add or subtract 360 degrees from the terminal side of the angle. So down below it says find one positive and one negative angle that is coterminal with each given angle. So the first one we have negative 120 degrees. If I want to come up with another angle, I could say negative 120 degrees. Let's do the negative first. Minus 360 degrees would give us negative 480 degrees would be a coterminal angle. And if I do negative 120 degrees plus 360 degrees, I would get a positive 240 degrees. Those are both going to be coterminal angles to negative 120 degrees. Same thing with 400. Okay, so the first one here, let's see. If I did 400 degrees minus 360 degrees, that's going to leave me with 40 degrees. Now, they want one positive and one negative. Right now, I already got my positive, but if I add 360 to 400, I'm not going to get a negative angle. So let's take 40 degrees and let's subtract 360 degrees more, and we would end up at negative 320 degrees. So now we've got one positive and one negative angle there that are coterminal to 400 degrees. Okay, so hopefully coterminal angles is starting to come back to you a little bit. If you have questions about that, please make sure you're asking in class. But one more time, they're angles that share a terminal side when graphed from the standard position. All right, so let's go on here. A little bit more terminology that we want to just make sure that we talk about. Reference angles. Okay, and reference angles are the acute angle. Okay, remember, acute meaning less than 90 degrees. Oops, I don't even want to use that there. Let's just say less than 90 degrees, right? So it's the acute angle formed between the terminal side of the angle and the x-axis. That's really important. Okay, so and we'll draw this down below with our examples. It says state the reference angle for each given angle. It will help to draw each angle first, and that is a big truth, right? It's so much easier in this unit if you're willing to draw the pictures out. So there is my circle, right? I'm going to go ahead and draw in my x-axis and my y-axis, right? Those are important to have there, especially that x-axis right now because we're talking about reference angles. So if we were going to draw in theta, which is 195 degrees, right? Remember, we're starting here at 0. When we start drawing this angle, we're going to go here. We're at 90 degrees. We're going to make it all the way to there, which is 180 degrees. And then we're going to go a little bit past that, right? We're going to go all the way down to about right here. So this angle goes all the way to there. This is 195 degrees. Now, when they ask what is the reference angle, okay, so what we need to focus on here is the reference angle is the angle that's formed between the terminal side and the x-axis. So how many degrees are there between our terminal side and the x-axis? It's not very big, right? Because we went 180 degrees to here. That means that this leftover piece has got to be 15 degrees. So our reference angle, right, is going to be 15 degrees. Okay, remember 15 degrees is an acute angle, so that makes sense. Okay, let's do a 320 degree angle. So let's just draw a circle in. If you need to pause the video to draw it in there, that's fine. So let's get that on there. All right, and then we're going to take it, draw in our x-axis and our y-axis real quick. So x-axis runs right across there because that's where our standard position will start. There's our y-axis. Okay, so if I'm going to go 320 degrees, so I'm starting here at 0. I'm going around 90, 180, 270, and then we're going all the way to, what was it, 320, so it's going to be in this one. So it goes all the way down to about somewhere down here. I don't know if that's like perfectly drawn, but it's close enough. I know that this is a total of 320 degrees to go all the way around to here. Okay, now the reference angle, remember, is going to be the angle that's formed between the terminal side and the x-axis. Okay, so it's not even really in my angle, it's the rest of it on this one. So how far, if this is 320 degrees, right, how far do we have to go to get all the way back up to 360 degrees? Okay, so if we did 360 minus 320, that's 40 degrees. So our reference angle here is 40 degrees. So our reference angle there is 40 degrees. Okay, so I'm going to continue to look at these, but just remember, I don't know if you remember this or not, but this is going to help us when we're identifying all the different corresponding angles as we're going around the circle. Okay, so we'll talk a little bit more about it as we get deeper into the next lesson. If you have questions or concerns, please make sure you're reaching out. Otherwise, thanks for watching.